So, we have all of our steps done on our sheet now. Okay? So, make sure that your steps, or that your sheet, looks like these steps, or that you have all of these steps ready to go, so that you can utilize this as a resource this week and next week, and for the test, or studying, preparing yourself for the test on next week, Thursday. Okay? All right? So, if it says analyze the graph of a rational function, that means that I have to have the graph of a rational function. So, how do I produce the graph of a rational function? First step. What do I do first? Again, you all have this literally in front of you right now, provided that you've made yourself a cheat sheet. First step. Domain and vertical asymptotes. How do I do it, Logan? Set the denominator. The other D word. Yep, the other D word. Denominator. Set the denominator equal to 0. Okay? All right? I got to pause here for. Okay? So we find the domain and any vertical asymptotes, and we do that by setting the denominator equal to 0. Okay? And then we solve for it. And that goes into any place that it does equal 0, that goes into our restrictions. Fantastic. Step number 2. Or step 1.5, yes, I'm sorry, yes, the next step. Okay. Okay. So we're gonna simplify by factoring. If we can. And then if something crosses out, we cross it out or cancel it out. And if a factor does truly cancel, what does that immediately, what light bulb goes off in our brain? What does that mean? That there's a hole, and I got to do step number 5. Okay. So if we cross something out, that means that there's a hole later on in the problem. Okay. Step 2. Horizontal asymptotes. Okay. If there is any, right? Okay. How do I find the horizontal asymptote? Compare your degrees. Yep. Okay, what are my 3 options? Big over small, small over big, and the same. If they're the same, then what? And where do I get A and B from? Lead coefficient of the numerator, lead coefficient of the denominator. Great. Okay, so that's that one. Small over big. That's y equals 0. Big over small. But in that big over small case, what else am I looking for? If it differs by 1. If it's bigger by 1, then what? Then that gives us a slant asymptote. See if I can fit differ in there. Oh, look at that, I can. top is bigger by 1, there's a slant asymptote. Can I have a slant asymptote and a horizontal asymptote at the same time? No, can't do it. Doesn't fit the criteria. Okay? All right? Step number 3 then. Find my int, my y-intercept. Okay? How do I go about finding my y-intercept? So I find f of 0, or I plug in 0 for x. Okay? What does all of my y-intercepts look like? All of them have the same form. 0 comma some number. Step 4. Find my x-intercept. How am I going to find my x-intercept? Somebody other than Antonio or Jenna, what are these going to look like? Number comma 0. Okay. Logic here now. How many intercepts can I get in step number 3? In step number 3. Or 1 or none. That's it. You can only have one y-intercept or no y-intercepts. Okay? In step number 4, how many x-intercepts can I get? How many x-intercepts can I get in step number 4? The degree of what? The degree of what? What? The numerator, yep, because that's where we get them from. Okay? So whatever the degree of the numerator is, that's how many x-intercepts I will have. Okay? Alright? So whatever the biggest exponent is on top, that's how many x-intercepts I have on my graph. Okay? Step 5 then. Got to find the holes. How do I go about finding the hole?
Set what was factored out equal to 0.
Okay. So I only do this if I factored something out in step 1.5. Okay? So the first thing that I do is what? Okay? So I set that factored out factor equal to 0. Okay? And then what? And then plug that into my new function, my remaining function, right? Two-part question. What does the whole look like? 1, in my list of things, because remember, you always have a list of things that I'm looking for. So what does the whole look like in the list? And part 2, what does the whole look like on the graph? Okay. So what does the hole look like on the list? What does the hole look like on the graph? Marley, what does it look like on the graph? It's an open. Do I put a dot in the middle of it? No, it's literally a hole in the graph. Okay, so on the graph, it's a circle, an open circle with nothing inside of it. Okay. On the list, what does it look like? A point, right? Okay. Where do I get those? So it's going to look like that, right? It's going to look like a point. No equal sign. Lots of equal signs in the hole on the formative that you took yesterday. Okay. The X part, where do I get that from? Of the hole. It's part A of that step, right? The Y part. It's part B. Okay. The reason that we do part A and part B of step 5 is because that's what produces my hole. Okay? All right? So that's the hole. Step 6. Slant asymptote, right? Okay. How do I go about finding the slant asymptote? Okay, so that's our first clarification. So top degree is bigger by 1. Then what? So the first step is I actually have to divide the top by the bottom. Oops, whoa, tap the brakes. Start over. How am I going to go about dividing the top by the bottom? Or synthetic or long division. Okay? So remember, I can use synthetic if my numerator or my denominator is 1x plus or minus some number. That's the only time that I can use synthetic. Otherwise, I've got to use long division. Okay? Then what? Then I'm going to drop the remainder. Then what? Is what's left over? And what form is it going to take? Okay. Then what? When I put that on, how does that go on my graph? Or how do all asymptotes go on my graph? Dashed lines. Dashed lines. Somebody, I don't remember who, somebody on their homework put solid lines for their asymptotes. Okay? Dashed lines on that. Yep. All right. Step 7 then. Using a T-chart, yep. Find some other points. Because we like to have preferred, we like to have 3 points in each zone, and the zones we divide up by vertical asymptotes, so that we know where the function goes.
Question.
Mm-hmm.
My formative, I kind of like knew like how the graph was gonna look, so I kind of just drew the shape of it. Is that okay, or do you want exact formative?
I mean, I'd like it to be as exact as possible.
Okay.
You know what I mean? Because what I mean by that is, so in red here is where the function should have gone, let's say. Okay? And so if you go like this, I would take off for that. You know what I mean? Because, yeah, you got the where it's supposed to be, but nowhere near where it actually should have been. Okay? You know what I mean? So, yes and no. If you're close, if you're in the ballpark, I'll give it to you. But if you're just kind of way off, then no. Okay? Alright? Oops, I did miss a little bit on there. Alright, let's do one here. Shabam. Okay? Roughly, how long should these take? At this point in time, 5 to 7 minutes, depending on how many steps we have to do. Okay? Alright, I will set a timer just so that you can determine your time frame. Okay, I'll set the timer for 7 minutes. Alright, so that was 7 minutes. Okay, so how can we get faster at these? How can we get it down so that we can get this problem done in 7 minutes? Practice. Got to practice these. So don't be sitting on your homework. Okay? Don't be waiting to do your homework until next week, Wednesday. Get your homework done now, because you're going to get another one on Friday. Okay? Alright? So, here we go. First step is I need to set my denominator equal to 0. That gives me x equals 2. I need to say then that the domain here is all real numbers, but x cannot be equal to 2. Step 1.5, x minus 5, x minus 1, all over x minus 2. Nothing factors out, so this stays. My vertical asymptote is x equals 2. Okay. Horizontally, my asymptote, I have a degree of 2 on the top. I have a degree, I have a degree of 1 on the bottom. That is a none case. However, we have a difference of 1. That should be a B. So that tells me I automatically have to do step 6. Okay? My y-intercept, f of 0. So if I put 0 into my function, I get, on top, I would get 5. On the bottom, I would get negative 2. So that gives me a y-intercept of 0, comma, negative 5/2, which is negative 2.5. My x-intercepts, I set my numerator equal to 0, x minus 5, x minus 1, set that equal to 0. That gives me, I'm going to pull this down a little bit more, x minus 5 equals 0, so x is equal to 5. X minus 1 is equal to 0, so x is equal to 1, which means that I have x-intercepts at 5, 0 and 1, 0. 1, 2, 3, 4, and 5. Okay. Did anything cancel out? Nothing canceled out, so that means we have no hole. Okay. My function, again, was x squared minus 6x plus 5 all over x minus 2. We differed by 1, so we will have a slant asymptote. Luckily, I'm in this case where I can do synthetic division. I've got 1x minus 2, so I can say that x minus 2 equals 0, so x is equal to 2. And then I synthetically divide 2 into my function. 1, oops, tap the brakes, that should have been a 1. I multiplied in my brain already. 1, 2, negative 4, negative 8, negative 3. Drop the remainder, and that leaves me with a slant asymptote of y equals x minus 4. So go back to my graph now. X minus 4 has a y-intercept of negative 4, a slope of positive 1. So we're going up 1 and right 1, or down 1 and left 1. Throw that one on there as a sliggity slant. Oops, wrong way. Okay. So we have no holes, okay? And like you were saying, we kind of know where this function is going to go, right? Because we have 2 points over here on the left side of my vertical asymptote. So we could figure out one more point. So in my brain, if I put in like 5, okay? If I put 5 into my function, I get 25 minus 30 is negative 5. Wait, tap the brakes. Negative 5. Sorry, we're putting negative 5 in. 25 plus 30 is 55 plus 5 is 60 all over negative 7. So that's going to be a little bit less than negative 9. 5, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's going to be right down in there. Okay? So that shows us kind of where we're going there. If I put in positive 3 into my function, I get 9 minus 18 plus 5, which is negative 4, all over 1. So that's going to be negative 4. So that's going to be right there. So that kind of tells me, that just gives me a little hint as to where my function is actually going to go. Okay? So that I am being as accurate as we can be. Okay? Good? All right. Same thing. Here's another one. Let's do it. So, step number 1 says I go x squared minus 4 equals 0. X squared equals 4. X equals plus minus 2. So I have a domain here of all real numbers, but x cannot be plus or minus 2. Out of the top, I can factor out a 3. The bottom factors to be x plus 2, x minus 2. Nothing cancels out, so that's everything's gonna stay the same. So we have at positive 2 and at negative 2. Horizontally, top is 1, bottom is 2. That's y equals 0 as a horizontal asymptote. A y-intercept, plug in 0, I get 0, comma, negative 9/4. An x-intercept, 3x plus 9 equals 0. 3x is equal to negative 9. So x is negative 3. So we're looking like that. Okay. So let's put some asymptotes on this graph. 2, negative 2, 0, negative 9/4 is negative 2 1/4. Negative 3, 0 is right there. Okay, so there we go. Now, the question is, can we have an intercept on a horizontal asymptote? Yes, we can. Can't have it on a slant, can't have it on a vertical, but yes, on a horizontal we can. We can cross over a horizontal. Okay? So, if I put in, let's go with negative 4. If I put in negative 4, into my function was 3x, so that's going to be negative 12 plus 9 is going to be negative 3. Negative 4 squared is 16, minus 4 is 12, so that's negative 1/4, so that's up here. So that's going to be, because it's got to turn to the asymptote and it only crosses once, this side here is going to look like, it's going to come from below and then cross over. It's going to look like that. It really can. Really, really. Horizontals, the only thing that the horizontal does is it tells us end behavior. It tells us what the function is going to be approaching at positive infinity and negative infinity. We can cross it as many times as we want. Verticals, no way, no how.
Yeah, that could have gone like that. Is that when you check?
Yep. Okay. Now, I don't have any more intercepts, right? Right? I only had one x-intercept, so it only crossed the x-intercept once. So this one has to go like this. Because if it turned up, I'd have another x-intercept. I don't have one, so it's got to look like that. Okay? Then I come over here and I say, all right, let's go with 3. 3 times 3 is 9, plus 9 is 18. 9 minus 4 is 5, so that's going to be a little bit more than 3. Okay. And I know it doesn't cross the x-axis again, because there is no other x-intercept. So I know then that this one is going to come through like that. Okay. Use your tools, use your logic, use your knowledge. It can only, if it's going to cross the x-axis, there's got to be an x-intercept for it. We only had one, so this one only crossed once. Okay? I remind you that you should all have a purple homework packet, and that homework packet is going to be due next week, Thursday. Okay? Friday of this week, you are going to have a quiz.